in listen-only mode.
Hey everybody, and welcome to our IoT Use Cases and Applications webinar. Thanks everybody for joining. I know we have a number of folks in North America and all across the world in all different time zones, so thank you all for making time. We have two folks here delivering the webinar. Myself, Sam Elsner. I'm a senior applications engineer, and I manage our team of sales applications engineers here at Kepware. And as a colleague of mine, I have Ray Labby, a senior applications engineer with our team, and we'll be delivering the presentation to you today. Before I begin, can folks just confirm that you can hear me okay? You can type just a yes into the questions pane. Okay, good. Looks like through very well. Thank you all for answering. Okay, let's jump right into it. So just to level set quickly on who we are and what we do, Kepware Technologies, it has been established in '95. We're focused on developing industrial connectivity software, and we've been doing this for roughly 20 years now. Last year, we were acquired by PTC, which is a global provider of technology platforms and solutions. And we now serve a wide range of customers in a variety of vertical markets. Kepware software and technology platforms are distributed in over 100 different companies through a partner network. We've been honored with numerous accolades that speak to innovative industrial IoT solutions and product quality and company culture, and that in large part is due to customers and integrators and resellers like all the folks who joined the webinar today, supporting us and carrying our products into really interesting and valuable applications and solutions for end users. So thank you all. We are talking today about IoT use cases, and I wanted just to level set quickly on KeepingServerEX itself as a technology platform before we jump into it. This is for anybody new to Kepware, this is our flagship connectivity platform. It's called KeepingServerEX. We'll be in the discussions today leveraging KeepingServerEX and drivers within our 150 plus driver toolset. We have client drivers that connect to software applications and device drivers that connect to hundreds of different types of hardware. We support lots of different kinds of traditional automation interfaces like OPC and proprietary protocols like Wonderware SweetLink and interfaces for iFix and our sister company ThingWorx as well. And then we also will be talking in detail today about new IoT solutions, i.e. protocols that we've embedded within Kepware. And that's a host of different ones, but MQTT and HTTP are going to be the focus of today's discussion. Okay. So just a quick agenda. We're going to cover what is, in general, what does it mean when we're talking about the industrial Internet of Things. We'll then jump into use cases and applications. We'll just do a quick level set specifically on the IoT Gateway plugin for KepServer, and then we'll wrap it up with a conclusion and move forward from there. So just to start out, we want to know what part of the world you're from. So I'm going to run a quick if GoToWebinar agrees with me, I'll run a quick poll question for everyone here. Just give me a second or two.
All right, so let's go ahead and close the poll and share the results here. So it looks like a majority of you are from North America, which is great. No, that's where we're based here in the United States, but we see a lot of people from Europe and also Asia Pacific and South America as well. So welcome. Great to hear you guys and see you guys joining us today.
Okay, thank you, Ray. So now that we've answered the poll question, we'll jump right into a definition of the industrial Internet of Things. So just grabbing a definition out of my hat, right? It's connecting industrial equipment to the internet to increase the effectiveness of equipment and the systems to which the equipment participates, right? So is that really it? Is it always stuff connected to the internet? Does that make it the industrial internet of things? From our perspective, SCADA and automation environments have been creating internets of things for a couple of decades, right? We may not be using the capital I internet, the public internet backbone to connect all of our equipment together, but it's the topologies that we're seeing today being described as
Okay, so just so you guys know, it looks like GoToMeeting completely crashed on Sam's laptop here. So we're going to take a moment here. I've had a couple questions come in while we're sitting here talking about what we're expecting to discuss, and somebody had a couple questions about narrowband IoT and maybe LoRaWAN. We're not going to focus on those specific technologies today. Ultimately, those are defining transport layer interfaces that can move various types of data sets across networks. So we're actually going to be focusing more on a couple of the applications that we do have with some of our early adopters of our IoT Gateway platform. So it's going to be focusing more on standard HTTP and MQTT interfacing with the IoT Gateway, but applications that sensors might be built using LoRa, as well as applications that might use like a narrowband infrastructure. Those are certainly becoming more adopted in the marketplace, and things like narrowbands really identifying the transport of the information. So whatever that information might transport over a narrowband IoT infrastructure could be easily consumable by KepServer, depending on what the data is coming from a application layer protocol perspective. All right, so it looks like we are seeing your desktop, Sam, through the GoToWebinar now. So it looks like we can probably at least get it set up here in a second. The other question was about Azure cloud analytics that we support. So with our IoT Gateway, we really use some standardized mechanisms to move that data, and ultimately it's what can those analytics tools ingest for data specifically. So RESTful interfaces, MQTT, are commonly used in this space for accessing that data. So whether it's Azure, whether it's AWS, whether it's some other proprietary, or I should say, other industry or solution providers platform, typically we can use our tools to be able to move that data into those platforms. So it looks like we can see your screen, Sam, so we can...
All right, thanks everybody for bearing with me. It's always fun when you do a live webinar and the webinar hosting software crashes, so maybe some of you have felt my pain, but thank you for bearing with me. So like Ray was discussing, there are lots of different topologies, lots of different technologies here. So it can be really tempting and simple to create a single definition for all this stuff. Like I said in the previous slide, if the goal is simply to increase the effectiveness of equipment and systems, I mean, there are lots of different ways to do that. So is that really what IIoT is all about? Is that too broad a definition? And then what if we don't use the capital I public internet? Is it still considered IIoT? So there are lots of questions, right? And the only thing, when we're stewing about this at Kepware, when we're putting our heads together to figure out what IoT is, the only thing that we could really conclude is what it means to us. And it's a recognition that IoT means a lot of different things to a lot of different people depending on who you are and what you're trying to do. So on the left, you might have a topology that you created just yesterday, and you've used new sort of web-oriented technologies to do this. You have a flat sort of network design with lots of points of connectivity versus a hierarchical sort sort of segmented network. And then you have a picture of a cloud included. You might have cloud integration. So is this what IIoT needs to look like, right? With internet access, with flat network designs, right? Or could something on the right side be considered IIoT? I mean, these are individual networks connecting to each other for internetworking, and it's certainly an industrial environment. It doesn't use the capital I internet, but does that really mean that it's not IIoT? And so for us, we arrived at a definition of sort of a catch-all definition that was safe for every kind of application that folks might want to create with either tools new and old. So for us, the industrial Internet of Things is really, in some ways, as it always has been Kepware's mission, to us, IoT is about accessing any and all data from any parts of the industrial automation system. So sometimes that might look like something on the right, where you have a traditional SCADA, at a hierarchical sort of higher network level, where you're not leveraging the capital I internet, but it may look like something on the left where you have a more flat sort of architecture, and without the traditional phrases like SCADA and HMI being involved. So what we're going to talk to folks today about are real customer applications that leveraged what Kepware defines IIoT as, which is increased data access, and they're using some other concepts for a variety of different business purposes. So these are concepts generally under the umbrella of IoT or IIoT, but it doesn't, other folks have applied these same technologies and never called it IoT before. So definitions being what they are, these are stories about people and organizations doing interesting things with new and old technologies, with new network topologies, with old network topologies, and we thought it would be best, instead of trying to define IoT, just to tell stories about what people are doing, and then folks can define that as IoT or IoT if they'd like. So we'll cover scenario one, which is industrial data over web services for MES, or manufacturing execution. This was a customer of ours. They're a global customer. We'll go into detail, but it's an automobile assembler. Then scenario two is our mobile and web interfaces for manufacturing systems. That's an injector, or a company that does plastic injection molding. All kinds of different plastics and rubbers are created. They enhanced their production facility quite a bit. Scenario number three is using industrial data for cloud and big data systems, and this is a big car company that has leveraged the capital I internet and some other techniques and tools to develop some sophisticated business systems. So we're going to jump into this, but before we do, we're going to run just another quick poll question. So this one is, how familiar are you with KeepServerEX? So I'm going to go ahead and start the poll. And we'll let it run for maybe a minute or so. All right, looks like a healthy number of folks. This is an introduction to KepServer, which is great. Thank you for joining. All right, we have about 80% of folks voted in at 30 seconds into the poll, so I'll let it run for another maybe 15 to 20 seconds. All right. Great. Well, thank you everybody for voting. This is wonderful. The majority of folks don't have familiarity with KepServer. This is fantastic. So thank you so much for taking time out of your day to learn about the products that we have to offer and the stories that we're telling today. All right, so I'll go ahead and close the poll, and then I'll go ahead and share the results. Excellent. Okay. All right. So I'm going to move on to the next section, which is a use case around industrial data over web services for manufacturing execution.
Excellent. Hello, everybody. My name is Ray Labby. I'm a senior applications engineer, as Sam alluded to earlier. And the first use case that oftentimes companies and users aren't thinking about when we talk about industrial Internet of Things is the idea of leveraging web services directly for their manufacturing execution system. And the company and the use case we're going to talk about here is from Faurecia, who's a tier 1 supplier of exhaust systems and interior components to many of the major auto manufacturers like VW and Ford and GM, et cetera, across the globe. They have a lot of different facilities, over 300 facilities worldwide, supporting not only vehicles such as those manufacturers, but also in more industrial transportation type vehicles like larger trucks for Cummins and et cetera. So what Faurecia's challenge was specifically around the IoT or their use case and what some of their challenges are for their use case is needing to meet some of their customers' demands for traceability data. And when they were looking at their current implementations of their MES systems, they really had the challenge of, okay, we need to revamp our internal MES system called IJ Core, which is an internally built system that was built on, I think it was built on C programming and using OPC as a means to access data from KeepingServerEX specifically on their manufacturing lines. So when they looked at these challenges of how do I enhance our MES system so we can get this large amounts of traceability data quickly and easily to our customers, what they decided to do was build a next generation MES system that was built upon web services to handle and manage the data tracking as well as the report generating to their end customers, essentially who they're supplying their components to. And what they found is moving in this direction, because their MES system design was built upon web services, they identified the IoT Gateway as a great solution to be able to access that data for traceability purposes and integrate it easily into their MES system because they were already using web services technology to integrate with their data stores and presenting the reporting and visualization to their end customers as well. So that's where the IoT Gateway really came into to be such a great tool for them to easily and rapidly deploy this new generation MES system for them to use. Now, as a demonstration, what we're going to do is I'm going to use a couple tools from Node-RED to basically mimic one of the scenarios that they do within their manufacturing lines by monitoring and executing to one of their processes to access data from torque tool devices through a PLC and be able to do that exchange, deterministic exchange to verify that the data is correct, to verify their process was executed correctly, store the data, and then be able to release the line to move on to the next component. So if we look here, what their messaging exchange, and for those that are in the industrial spaces, probably isn't too foreign, the idea of taking a few steps interfacing from your MES system with your PLCs to identify what's the part information that the tool at the line is going to be working on, whether the information is ready to be ingested, whether the tools on the manufacturing floor are ready to be used, so to essentially confirm that the setup and the configuration of the recipe or the information in the PLC is good to go. Let the operator or the automated process run, and then provide the ability to be flagged and access the results from that manufacturing process, and then be able to repeat that step over and over as new components move in through the line. So what I'm going to do now is, now that I've sort of explained a little bit about the data flow process, I'm going to use Node-RED as a tool just to simply show this this type of setup. So let me go ahead and share my screen. All right, so can everybody see my screen? Please respond yes in the questions pane if you can. Great, thank you. So Node-RED is a web services-based tool where you can set up HTTP and MQTT, and it's really a graphical flow design where you can process data that's coming in to be able to move it to other systems, to be able to respond back, be able to command results based on certain information that's being responded from some other web services system. So if we look at KeepingServerEX, what we have as part of this demonstration is essentially a PLC with a specific line that has a certain data set that's exposed for a torque tool device, where you're going to record the 7 results of the angles and the torques in the PLC, but then there's going to be some Booleans that are going to identify the statuses of the PLC and whether it's ready to receive the part information, the job information, as well as when that process is complete. So from a KeepingServerEX configuration perspective, what Faurecia is doing is setting up 2 things. One is they're setting up a client agent that's going to be publishing specific data sets out to the MES system to trigger the MES system to take action. So this is where you're going to see statuses from the cycle, whether the cycle is currently running, whether the cycle is completed successfully with an OK or a not OK bit, as well as some information about the product version that's being processed by the PLC and the industrial line itself. And these flags are going to trigger the MES system to take action. Now, when the MES system needs to take action, that's where we're going to set up a HTTP server agent in KeepingServerEX that can be the endpoint that the MES system can command data and also do device reads through to access the data sets from the PLC. So once the process is complete and the complete flag is notified here with an OK, what the MES system can do is, okay, I'm going to go and tell me what those torque values and those angle values are on the PLC right now by doing an explicit read through this HTTP server endpoint, which then goes to the PLC and pulls in the data. So you can see the services provided through the HTTP agents, whether it's the client agent or the server agent, closely resemble the similar services that you need when you're using a manufacturer execution system. The ability to subscribe to data that would be done through an HTTP client agent that's going to publish data on data change, or if you need to do explicit reads or writes down to your PLC, a server endpoint in KeepingServerEX's IoT gateway allows you the ability to be able to interact with the PLC, similar to OPC services and other services that you would commonly use down on the manufacturing floor. So what we have operating now in this example is the ability to execute this through a web services interface. And what I've done here is just sort of build a quick flow diagram of this process where the flags are going to be inputted, and then you're going to be checking the flags for the certain statuses. Once you actually see that the process is complete, you're going to be able to read the results from the process. This is where we're going to be pulling in that data from the PLC with explicit device reads to the KeepingServerEX's HTTP server endpoint. And then we're able to log these to a disk while we reset the statuses and sort of set up the line for the next component to be worked on by the operator. So we're going to do a PLC check to verify that the PLC is ready to receive the next part information based on its reset internally. And then once that's verified, we can gather the new part information from, let's say, a database, whether it's an Oracle database in your MES system, or maybe some information from another system like an ERP system, and be able to send that information down to the PLC and trigger to start the process over again. So again, this is using Node-RED as a tool just to mimic this workflow, but this workflow would be very similar to what you would build in an MES system. Not only can you do it in any of the other interfaces that KeepServerEX supports, you can also essentially do manufacturer execution systems with HTTP and KepServer. Excellent. So I think we'll move on to the next use case. Thanks, Sam.
Okay, thank you, Ray. All right, thank you, Ray. So I'm going to go ahead and share my screen, and we'll move on in the presentation. Excellent, okay. Okay, excellent. All right. So at this point, we're going to move on and talk about a different use case for web services within KepServer. This is mobile and web interfaces for manufacturing systems. So instead of developing a programmatic interface to something like an MES, one of our customers, Teel Plastics, they decided to create a point of management for people to manage systems through KepServer. And the way that they wanted to create this point of management was through web services and HTML. So Teel Plastics, they're an organization that extrudes plastics, tubing, and other types of profiles. So they're an organization that extrudes plastics and other types of profiles. So they have extremely highly skilled employees and a bunch of very unique manufacturing techniques. So they've really made a name for themselves in the made-to-order plastic tubing business. So they have a very productive plant and with a lot of highly trained folks. And so when they were developing this plan, they leaned on those highly skilled workers to take a lot of manual interaction with their equipment. And it worked very well for a long time, but scalability and productivity really needed an increase in a substantial way. So they produce lots of different products at various times throughout the day. Again, they're made to order, so they're constantly changing recipes. And then each line is going to require a custom recipe for every single product. So this recipe is different material inputs, different equipment utilized, different heating components, all kinds of variables that have to be adjusted to, create the right end product. All of that work has to occur frequently throughout the course of the day as recipes change. So all of the variables caused instances where human error impacted recipes. There was just too many variables for folks to consistently apply correctly, through manual operations by running all of those diverse pieces of equipment. So the deviations in product quality that resulted from this led Teel to find a different way to operate this equipment and facilities. So the challenge, again, just to reorient folks, multiple production lines, multiple recipes changing per product run, manual loading of recipes. So what Teel Plastics decided to do was to leverage KeepServerEX as the platform by which they connect their process control equipment and their injection molding machines. And they wanted to have sort of a custom, very flexible design for the interface for the human being. And so they opted to do something with web services instead of buying a commercial off-the-shelf tool. They were developing a rather small scale HMI for very specific production, and they felt that they could have some economies of scale if they leveraged internal expertise to develop this HMI. So in leaning towards web, they really then found that they wanted web services as a point of interaction with Kepware. They evaluated leveraging software development kits to bring in different types of OPC standards and other standards, but there's nothing simpler than the baked-in library to Ajax, say, developing an HTTP request. We can do that right within a web page. In fact, I'll demo that just now, just in a couple of seconds. So for them, being able to leverage HTTP made the point of interaction with Kepware just incredibly simple, and it's something that could be completed within half a day. And then they can move on to the more critical aspects of the environment, which is really developing a good operator workflow in that context of that HTML client, that HTML page. So from a practical standpoint, we've got KepServer sitting in the middle. It's talking to all kinds of equipment involved in fabricating the products of Teel. And then the operators are both using web browsers on desktop systems and mobile devices to interact with this equipment now. And they're doing that natively with Kepware. So the HTML page interacts directly with the tool called the IoT Gateway in KepServer. Within the IoT Gateway, KepServer is hosting a REST server agent. Basically, REST is representational state transfer. It stands effectively right now. It's most often applied. It's a design paradigm that's most often associated with HTTP. So they developed. With a couple of button clicks, they added the ability to host data points from KepServer via HTTP, so they could interact with those data points directly through a web browser, just like you navigate to google.com. So I'm going to go ahead and give a concept demonstration. Okay, so here I've got a virtual machine running KepServerEX version 6.1. This is our latest and greatest version of KepServer. And as you can see, I have a device connected. This is an Allen Bradley ControlLogix device from our lab environment. I've leveraged with KepServer the ability to automatically generate data points from the device. That's a feature employed on many of our drivers. And so you can see the structure of tags that I was able to find in the device. So this represents half of the work in KepServer for Teel. They had to connect KepServer to process control equipment. So if I connect a simple OPC client to this, you can see that I have data streaming back to me. We could use tools inside of KepServer. For those unfamiliar, we can use tools like our diagnostics view to actually expose the underlying protocol. Again, just to show you, this isn't smoke and mirrors. We're communicating live to a device in our lab now and bringing that data right now back into an OPC client. So let's move this data into an area where we can access it with something simple like a web browser or an HTML web page. So I'm going to add what's called an IoT Gateway agent to our KepServer project. I'll click Add Agent. And I have a few different agent options. I can instantiate an agent to push to ThingWorx, which is a fantastic IoT platform from PTC. Or I can create an MQTT client that pushes data to an MQTT broker. We'll talk a little bit about this in the next use case. I can create a RESTful client, meaning I am going to be responsible as the client for interacting with a target web server, and this is used for pushing data out of KepServer proactively, which is in part what Pharesia was doing and what Ray covered in the last demo. For this demo, I'm going to create a REST server, which again, REST is a design paradigm. It's representational state transfer. Effectively, it's the name is sounds like a triple word score in Scrabble, but the idea is pretty simple. It's just give the server that you're interacting with every single thing that the server needs to process your request within the request itself. So don't worry about establishing a connection and a session and a channel and all this other stuff first before you just go ask for something. You leverage a protocol that just lets you ask for something and lets you move on. So it's great for web, right? Because you don't want to stay connected to google.com if you're moving around. You've returned Google's web page, and that's what you get. So similar idea with REST and HTTP. So HTTP is RESTful. So to increase the level of understanding here, I'm just going to name my server agent HTTP server. That's simply what it is. Now I'll pick some properties on this HTTP server. I'm going to allow all of the different domains that I see come in for the purpose of demos, but this is going to allow blacklisting and whitelisting of clients based on domain name. But out of the box, we enforce security, we enforce HTTPS, we disable the ability to write to data points with the agent, and we don't allow anonymous login. So we force users to authenticate with us using Kepserver's user manager, which is available here. For folks interested, we don't yet support Active Directory integration with this user manager or LDAP. That's something that we have on our backlog, and it's certainly something that we've heard is desirable. So it should, you should see that coming at some point in the future. I can't make any guarantees, but it's certainly higher on our backlog than some other items. So now for the purpose of the demonstration, I'm going to back out all of the security that Kepware instantiates out of the box. I'm going to disallow or turn off, encryption. I'm going to allow anonymous login and then click finish. So you can see some confirmation messages here. For those interested, we are running this IoT gateway as a Java virtual machine, but it's server-side Java code, so its level of security is similar to what Kepserver's is in terms of a native C++ application. We're actually running the Java virtual machine within a Kepserver C++ executable. So now I have this HTTP server available. If I open it up and I go to the client area, I can jump into the API guide for using my REST server. So I have 3 different kinds of commands I can issue: browse, read, and write. We have this is similar to the functionality that you get from something like OPC. So if I wanted to browse the server's available data points within that particular agent, you can see the URL I would use and the HTTP method. So what's kind of fun is that, my browser issues HTTP methods called gets and options, and I can actually, just like I'd go get a web page from Google, I could get the information at the end of this browse URL. So I go ahead and issue a browse command to our agent. I actually don't have any tags created in there, but you can see that the web browser handles the response directly out of the IoT gateway. So there's nothing in between me and Kepserver. This is just a simple generic web browser from Google Chrome, interacting directly with Kepware. And the data that I'm getting, or the data that the server is returning to me, is a JSON packet. So now let me push a little bit of data into the web server, and then I'll show you live changing data in the web browser, and then we'll move on to just a quick little HTML page to give you an idea of what you could do. So I'm going to grab a friend of mine, Gary's Big Array. I'm going to grab Gary's Big Array and put a couple of Gary's Big Array tags into my IoT Gateway agent. We can offer 2 different types of read behavior. One is a simple sampling, and then clients are reading from cache. So that's fast access, non-critical, don't need to know specifically at that moment in time what's the value in the controller. Oftentimes though, especially for manufacturing execution, it's important for the MES to understand at the moment that the MES asks for it, what value is present in the connected device. And so when we do something like that, we offer the explicit readability per tag or per data point. And that when a read comes into that particular object, that'll actually activate the driver to go read from the device versus just setting up the driver to scan at an interval and then all clients are just reading from the web server's cache. For the sake of the demo, I'm just going to have a sampling routine run at 1,000 millisecond sample rate or 1 hertz sample rate. And so my cache will be populated in the web server at a rate of about 1 second. So now if I go and do that browse command again, you can see I've got a bunch of data points in there. And I could do things like issue a get to my read URL. So my read URL is built with a simple syntax of read separator as a question mark and then ID is equal. And I could take one of these data points or tag objects and I could actually issue a get directly to that tag object. And if I hadn't included the quotation mark in my tag, instead of getting a tag invalid, I would get a value. And there we go. There's the value. So as I refresh this page, I'm issuing gets. You can see that value hasn't changed. But if I add in, say, a system tag from Kepserver, and I issue the get again, you can see I have an extra tag in here now. It's the Kepserver system time tag. And so if I issue a get to my system time tag, you'll actually be seeing changing data in the web browser. There we go. So what can you do with this kind of interface? Well, it's really simple to build a very usable web client with something like this. So this is an example web client that our team threw together in just a couple of hours. It leverages HTML, and then it leverages the AJAX library for submitting HTTP commands. And so this represents something similar to what Teel put together, which is a couple of things. It's direct interaction with KEPServer from a website or a web browser and a web page. And it represents a very custom operator workflow, because with this kind of, with HTML, you can really design any kind of interface you want. And so they created a very specific workflow for their very specific manner in which they wanted their very highly skilled operators to interact with their equipment. So if I push our connect button, you can see that, hey, my website shows me that, hey, I've got 16 tags on my server. I'm going to go ahead and display all tag IDs. There they are. If I wanted to say automatically refresh all tag IDs, now I have an AJAX script running behind the scenes that's issuing a GET to the system time tag at a specific interval of 1 second. And if I wanted to, you'll have to excuse me here. I don't know if I can write to this endpoint, this piece of data, but let me try. Let me try something simpler. I'm going to go ahead and write a value of 1 to Gary's big array. Looks like the write succeeded. Cool. So I should be able to get feedback. Okay. Well, anyway, the write operation, the tag may not have been writable actually. And what's likely happening is the PLC is running ladder logic to automatically shift that value back down to 0, because Gary is a member of our engineering solutions team, and he may or may not be using this device to do some pet projects and testing. So anyway, so that's the idea. You can develop any kind of workflow you want within a tool like this if you have the expertise. It's certainly not as easy as going to an off-the-shelf piece of software to build visualizations and applications for you, but if you have expertise in HTML and AJAX and other kinds of libraries that can issue HTTP requests to Kepware, then it's really easy for folks to build a very highly functional HMI and skip databases, skip all that stuff in between, and just interact now directly with Kepware's IoT Gateway. So that was what I had for this particular demo. I'm going to move on, and we'll talk about our last use case of the morning.
Excellent. Thank you, Sam.
Okay. All right, before that, a poll question.
Yeah.
Oh, can't forget about the poll questions. So I'll go ahead and run a poll question. It's, what's your interest in KEPServer for IIoT? We've had a lot of wonderful questions come in, so I'm garnering interest, everything from wearables and first responders to traffic control systems and others as well. So let's formalize that interest a little bit and maybe tell us more specifically what you're up to. So me personally, as Sam, I've tried to create 4 or 5, typical use cases, and then a catch-all. So I hope hope not too many people need to fall into the catch-all, but certainly I would love to hear about other kinds of IoT applications that may not be listed. Now we've got about 40% of the folks voted in, about 30 to 40 seconds in. All right, we've got about 70% voted in, and it's counting down to about the minute mark. I'm going to cap it at the minute mark and then show you the results. All right, about 3/4 of the folks voted, and I'll go ahead and share the results. Excellent. So we can see most folks are interested in integrating with various web services. So this is great. This is exactly our use case coming up. And a healthy number of folks have integrated with Azure as well, maybe Amazon Web Services. Excellent.
Yeah, it's a really balanced group between these different use cases, so it's great to see.
Absolutely. Okay. So I'll turn the mic over to Ray, and he'll talk about industrial data for cloud and big data systems.
Excellent, thanks, Sam. So we've talked, the two use cases we've talked earlier have been truly sort of focused almost internally to the operations space, and really the manufacturing execution use case where your line management and controlling the line is being developed across to integrate with KepServer using these web services interfaces in the IoT gateway. You also have simple app development that you can do to monitor your systems as well through KepServerEX by building simple web apps to interact with the HTTP server endpoint to maybe just get a quick visualization for certain users within your company or within your customer's company to be able to see that data. Now, the last use case is probably what's considered more of the general Internet of Things use case, where you want to integrate data from your industrial systems up into some cloud or big data systems solutions that are available. So for this particular customer, it's BMW, who I'm sure everybody's familiar is involved with making, some of the best luxury brand cars in the world, along with some other companies. And their production environment was really looking at ways of implementing the Internet of Things, Industrial Internet of Things, or in Europe often called the Industry 4.0 initiatives within their company, to use tools that are available in cloud infrastructure and systems like Azure, for instance, to be able to collect that data, do some predictive analysis for various use cases. And so what they wanted to do was start looking at how can we help minimize our downtime and take that predictive maintenance use case and focus on that as a first step. Looking to give their engineers tools to be able to look at accessing that data, putting it into an Azure platform, giving their engineers the ability to build applications or build simple visualizations to monitor what's going on in their assembly lines. So what they did was look at KepServerEX as the gateway component to their solution to be able to access data from their machinery lines. So a lot of the lines that they're looking are going to be using PLCs, such as PLCs from Siemens or Beckhoff, or maybe there are other OPC servers that are available in that line, and then using KepServer as that classic integration or aggregation point for the gateway, and then use the IoT gateway's MQTT client capabilities to be able to push that data up into an Azure platform, and essentially into what Microsoft calls the Azure IoT Hub. The IoT Hub is essentially what we call a device cloud, where different connections or different data sets can be pushed to that input into the Azure cloud, and then message bus services within the Azure cloud can be able to access the data from those devices. So you can help bring that data into a central location so that Azure applications or even other applications can use the APIs to access those message buses within the Azure platform. So if we look at the concept of the use case, you can see the classic aggregation of that data, bringing it into that single communications or connectivity layer of KepServerEX allows you to be able to bring that data in and then push it up to a cloud service such as Azure. So in BMW's case, what they're doing is they're using the IoT Hub, they're using some of the stream analytics components within the Azure cloud system, and then using other tools like Power BI to sort of visualize that data for their operators. So their approach to the Industry 4.0 was building this sandbox, this IoT sandbox environment, so that they can enable their engineers to quickly say, let me get some information about these assembly robots or these welding robots on this particular line, quickly configure KepServer using the tools in KepServer and the configuration API to access the data, build in the connectivity up to Azure really quickly, and then be able to get the data into Azure as soon as possible, so their engineers can then do the function of looking at the data, building out the machine learning analytics tools within Azure to be able to monitor the results and the operations of their machines, with the goal of minimizing downtime by optimizing their maintenance schedules on their robots and their machines. So it's a pretty interesting use case. We've had some other customers as well looking at these types of use cases where they're trying to push this data into what I call like a data lake, and a lot of times these data lakes are built upon cloud services like Azure or Amazon Web Services as well. So Sam, that's that use case for BMW.
Excellent. Thank you so much, Ray. That's great. So the interaction between KepServer and Azure, it's extremely simple to set up. Essentially, we're interacting with, as Ray noted on the slide, the Azure IoT Hub. We have a couple different points of connection between KepServer and the hub. We can push data to it using MQTT, and we can push data to it using our REST client agent for HTTP, and either work really, really well. The IoT Hub in Azure was designed to handle millions of data points streaming in per second. So it's from our testing, it seems like a very robust web server or a very robust MQTT broker, as we would say, and it's capable of handling a pretty good amount of data per second. And for KepServer, when we're dealing with data, it's not unusual for us to be dealing with hundreds of thousands of data points changing sometimes faster than a 1 Hz interval. We're often asked to get down to 50 milliseconds, and that's a lot of data streaming out. And so the systems that have grown up in traditional automation spaces are really good. They might not be the most flexible systems, but they're really good at high rate data ingest rates of unstructured data. But other technologies have grown up in different kinds of enterprise IT environments. From, for example, bioinformatics has created tons of file systems and things to deal with high ingest rates of unstructured data. So this, and object storage systems instead of traditional hierarchical file storage systems that rely on inodes and those kinds of things. Object storage systems are entities altogether different, and they can scale much larger, and they can take in a lot more data, say, per second. So, what's interesting is that these traditional automation, applications, they've been dealing with this high ingest rate for a long time, but things, Microsoft Azure isn't necessarily leveraging that technology. They're leveraging technology that might have grown up in social media that lets you tweet to, Twitter servers at, the rate of 1 billion data points per second. So now we're leveraging some technology, or this use case is leveraging technology that's grown up more in the enterprise IT space than automation to accomplish the same thing. So in all of our examples today, we talked about the use of the IoT gateway. So just for folks who are unfamiliar, again, the IoT gateway is a plugin for KepServer. And you can think of KepServer as having 3 layers, right? It has the driver layer, our southbound interfaces, we could say, where we're connecting to typically process control equipment, sensor technologies, databases, other software applications. We can integrate with third-party drivers through a number of tools. We have tools to graphically develop your own protocol drivers. So that's all our southbound stuff. And then we have a big layer on top that it provides server interfaces or publishing kinds of interfaces to move that data that we're collecting out of KepServer. And then in the middle is a layer of normalization, where when we get a tag object from, say, on the left from a PLC, the protocol that delivered that data, it might be entirely different than the protocol that delivered the sensor and actuator data all the way on the right side. But by the time the drivers hand the data to KepServer's server interface, it's normalized. It's modeled, you could say, in the same way, where we have an object called a tag and a value property and a timestamp property and a quality property that reflects our success or failure in obtaining that data the last time we tried. So that object is normalized. So by the time all of this different technology, the data from this different technology gets into KepServer, it all looks and feels the same and lets you work with it really simply. So just in my example, you saw me take a piece of data and load it into a web server. I didn't have to do anything complicated or scripted to do that because I leveraged that normalization layer. The IoT Gateway plugin plugs right into that normalization layer, and so the tag objects from the ControlLogix device can be accessed just with the graphical browsing window. Because I don't need to care, now that the data is normalized, I don't need to care where it comes from, really. It's interesting where it comes from, and that's useful context, but it doesn't matter to me technically. So I can have an easy user workflow that just says point to this object, bring it in the gateway, and then make it available. Boom. So we have these layers of KepServer. We've got a driver layer, a server core that normalizes data from all these disparate systems, and then we have interfaces on top for publishing and accessing the data. And then we have, something that sort of lives alongside. It's all one application, but we have these plugins that extend the features and functionality of Kepware. And so what we were leveraging today was our IoT Gateway plugin that hosts, IoT-centric, we could say, web service-centric or IoT platform-centric protocols. And we can connect to different IT systems. We do support SNMP alongside HTTP and MQTT. However, what we found is that most IT teams would prefer to use something lightweight and simple like HTTP versus something heavier weight like SNMP for just moving data out of a process control system. So we can stream data over MQTT, we can publish data over MQTT and HTTP, and we can publish data to the ThingWorx platform through a proprietary protocol called Always On. And then what this allows us to do is give enterprise business systems typically, or cloud systems, or even simple web pages for traditional process control service purposes, real access to real-time information from industrial equipment. And, this isn't a, we're giving you the tools, go develop your solution. This is an off-the-shelf product that you can get for relatively little money that accomplishes a lot in just a few button clicks. So it takes the challenge out of, sort of the spaghetti mess that you find typically in process control industries of equipment. So just to move towards a conclusion here, just to rehash, to us, the industrial Internet of Things means a lot of different things to a lot of different people, and so we've tried to distill it down into something that is something that works for Kepware, and that's simply to enable access to any and all data from any part of the industrial automation system. So that could be traditional layer 2, 3, and 4, or we could be bridging all the way to an IoT platform running in Amazon Web Services or Microsoft Azure, or ThingWorx running in the cloud, let's say. We talked through a few different customer scenarios. We had Forestia's use case for industrial data to their MES using RESTful interfaces instead of something heavier weight like OPC. We talked about Teel Plastics using simple web pages or highly developed but simply developed web pages interacting directly with Kepware for lightweight operator HMI, both on a thick client machine, thick computer, and mobile. And then we talked about scenario 3, BMW leveraging KepServer for industrial, to get industrial data into Azure, where they're conducting lots of different kinds of, math and logic computations there to enhance production. So to summarize all of this stuff, what we found is that you really don't need to define, generally speaking, let's say, you don't need to define all aspects of your return on investment, before you try something that might be considered IIoT. So, in our experience, you can find, many different areas to enhance without ever touching a cloud or the capital I public internet. Look at Teel Plastics. They're leveraging something that is traditionally thought of as an IoT protocol, like REST and HTTP and web services, but their application is very much traditional process control. So, the key is start with simple iterations and then expand where you find value, and that's what Teel did, that's what Forrestia did, that's what BMW did. They didn't have every single, component of their ROI mapped out before they started. They started, found some value in certain areas, and then kept iterating and moved forward. So from a practical standpoint, the apps, discussed in the webinar really didn't start with the complete end project in mind. They started with simple iterations and then were expanded when value was identified. Kepware as a company provides temporary licenses for testing quite easily. Just if you wanted to test something for 30 or 60 days, just reach out to us and let us know. We're happy to help you, both in temporary licenses and you can get access to our team, which are full of knowledgeable applications engineers. And then, as you take all of this opportunity to dig in and iterate, take a step forward and then assess what kind of effort or what kind of value that particular effort could provide. Maybe it doesn't make sense to add cloud into an initial IoT effort. Maybe it's just about sending some data to a web page or taking a ThingWorx free trial, and taking the ThingWorx IoT platform for a test run. Or maybe you want to take Azure's C# development area in the web where you can create sophisticated IoT solutions. Maybe you want to take that for a test run. So a lot of these organizations, Kepware included, are offering free trials of all this technology because again, you don't need to have all of the aspects of ROI in an IoT effort mapped out before you try it. There's a lot of free opportunities out there. There's free resources that you can leverage. And so we encourage folks to iterate, ask for free stuff, come to us and say, hey, could I get a temp license for testing this? I think I have a neat application. We'd be happy to support you on that. So thank you everybody for attending today's webinar. I hope you enjoyed it. I hope you found it was good. And we'll look forward to catching up with everybody on the next one. Ray and I are going to hang out for a little bit and answer some questions. And then once the questions are answered, we're going to sign off. So thanks again, everybody. You can reach out to us and connect to us within this contact information. And we've recorded the webinar, and we'll have the recording and the slide deck out within about 48 hours after the webinar concludes. So thanks again. Take care and have a great day.